Good morning students, welcome to Sri Guru online classes. In the last lecture we discussed the different observations of photoelectric effects, and different scientists discussed the emission of electron in the different methods, and also they concluded that the photoelectric emissions depends on substance, as well as it depends on temperature, as well as it depends on the conduction of materials also. Today we discuss the lecture number 3. Lecture number 3 on that photoelectric effect. The next is the very important is the experimental observations on photoelectric effects. Experimental observations on photoelectric effect. The experimental observations on photoelectric effect, just you make a experimental setup very clearly. We need evacuated tubes. Here is quartz window. Through this, the light of suitable frequency or suitable incident intensity of light is going to incident on this conducting plates or electrodes, and this electrode we called as a cathode, or we can say that C is nothing but emitter plate, and this one we called as anode, and this we called as a collector plate, and this evacuated glass tube, this is evacuated glass tube. Here made experimental on this particular, there is a rheostat. This rheostat connected with the key and high tension battery. Here we connect a potential difference, that is voltmeter, to this and it is going to variable and is connected to rheostat, and this we called as, this type of setup we called as a commutator. This type of setup we called as a commutators. Initially the positive terminal of high tension battery is connected to anode, and negative terminal of battery is connected to cathodes. Why you made connection positive means when a light of suitable frequency is incidenting on this cathode tube. When a light of suitable frequency is incidenting on this cathode tubes, these electrode plates emits the electrons and this anode plates collects these electrons, emits the electrons, and this anode plates collect these electrons. That's why in this particularly anode plates, the positively charged ions are attracted by these electrons. Then only the current is flowing in this circuit. The electron emitted from the cathode tube or cathode plate, these electrons are collected by this anode. Why this anode plate is collecting these electrons means this anode plate accelerated through a positively charged ions. Those ions are attracted these electrons, and that causes the electric current in the circuit. And this how much current is developed in this particular circuit we measured from a device is called as microammeter. On this particular device we are going to see the current variations, and this we called as a rheostat. RH means rheostat, and this we called as battery, that too high tense or high tension battery. And this V is called as voltmeter. Or voltmeter. And this microammeter, this is called as ammeter, a device which is used to measure the electric current in the circuit. And this commutator, the use of commutator means just the this positive to negative, this is initially this is negative and positive, these positive ions is connected to anode plates and negatively charged is connected to cathode plates. That's why this any type of source is incidenting on this cathode, there is a emission of electrons. Those emission of or those emitted electrons are attracted by this positively charged anode plates. If suppose this commutators reverse the circuit, there is a variations in that terminals, positive to negative, negative to positive. This positive to negative, if suppose we change that terminals, definitely the potential difference across this plates, cathode and anode plates, negatively increases, or same circuit means positively increases. We are seeing the voltage on this voltmeter. On this particular setup, the voltmeter or voltage potential differences increases as current flowing through this circuit. If suppose we reverse these terminals like this, or one more type, we are connecting like this means negative terminals is connected here and positive terminals is connected here means now I am going to connect in the reverse manner. Now initially it is connected to positive terminal of the battery, now it is connected like this, the negatively ions will move to the anode plate and repel these electrons, and positively ions is developed on the cathode plates, and more number of positive ions and less number of electrons are developed in this particular plate. That's why these are the things we discussed in this class, how these commutators will help us to see the variations or observations, experimental observations on photoelectric effect. We will discuss on this particular class. Now, first experimental observations, we will see the one by one effects. How this photoelectric effects on that particular things. What are the things are going to affect means, it affects on the nature of the metals or nature of the substance, and it also affects the particular intensity of light. If a given intensity of light is less, the electron emission is also less. Intensity more means the emission of electrons is also more. And if suppose we decrease in terms of frequency decreases, here also electron emission is also going to decreases. These type of things we'll discuss on this particular lecture. First experimental effects on photoelectric effect is effect of intensity of incident radiation, effect of intensity of incident radiation on photoelectric effect, photoelectric current. We'll discuss first one, that is effect of intensity of radiation on photoelectric current. We already discussed about this experimental setup. When a light of suitable frequency is incidenting on the collector plate, the emission of electron takes place. These anode plates collect the electrons and it forms the current on the particular circuit. This is about, we discussed already. The first effect is the intensity of incident radiations on a photoelectric effect. Listen here, intensity of incident radiation, we are increasing the intensity, but we are going to fix the potential as well as frequency. Potential and frequency are fixed. We are varying the intensity. It means that if the frequency changes, the current is not going to change. If a minimum frequency, up to that minimum frequency, the variation of current takes place, below which there is no variation of current, that type of frequency we call as threshold frequency. Threshold frequency. The frequency up to the minimum frequency, the emission takes place, below which there is no emission of electrons, that type of frequency is called as threshold frequency. Listen here, we should explain this effect on the basis of graphical. Here is intensity of incident radiation. Intensity of incident radiation and here is photocurrent. Photoelectric current. Listen here. When an intensity of light is incidenting, the intensity increases. Let us consider 100 watt. Initially, the 100 watt of intensity is incidenting on this cathode plate. Some amount of electrons emitting from this cathode tip, and these collector plates, initially it is connecting to positive terminal of battery, and this is connected to negative terminals of the battery. The potential is fixed and frequency means color is fixed. Color of light is fixed. Color of light fixed. Just to consider any type of color, the frequency is fixed. A particular intensity, 100 watt intensity, some electrons are ejected. That amount of current constitute in this circuit. The current, photoelectric current, is also increases. Due to this incident of this much of intensity of light, the emission of electron takes place. If suppose initially it is increases, again the intensity increases, 100 to 200 watt it is increases. Intensity increases, photocurrent is also increases. If the intensity of light increases, photoelectric current is also increases. Photoelectric current is also increases. As intensity increases, the current is also increases. That's why here photoelectric current is directly proportional to intensity. If the photoelectric current increases, linearly the intensity of light increases, or intensity of light increases, the incident light goes on increases, the emission of electrons are also increases. The emission of electron increases means photocurrent on this particular circuit is also increases. We can observe this on this particular device we call as ammeter device, and we can say that photoelectric current is directly proportional to intensity of light. This is the first effect on photoelectric current. These are the factors which depends on the photoelectric current. The first factor is intensity, next we can say that potential, next we can say that frequency, or we can say that the particular potential difference between the cathode and anode plate, and we can also say that the nature of that substance also. That nature of substance is also very important on the effect of photoelectric current. This is the first effect. We will discuss second one also. Listen here. As intensity goes on increases, we fix the frequency. Intensity increases, frequency is fixed. Frequency is not going to affect the photocurrent, only it affects the intensity of light. That's why we can say that photoelectric current is directly proportional to intensity of incident light. We will discuss the second one also. Effect of potential on photoelectric current. Photoelectric current, effect of potential on photoelectric current. Now here the intensity is increases, frequency is fixed. Frequency of light is fixed. fixed variation of intensity. Here we are varying the intensity, frequency of light is fixed. Just to assume yourself, frequency is fixed, the color of light is fixed. There is an incident light, yellow color. The incident light color is yellow, frequency is fixed, intensity we are increasing, by increases the potential difference. Now, variation of photocurrent by, this is a positive potential, and this is a negative potential that we called as retarding potential. Negative potential we called as a retarding potential. Now, intensity increases. Initially I am considering a certain intensity, that is, let us consider 100 watt. The first intensity of light is incidenting on the cathode tubes is 100 watt. This 100 watt intensity causes a certain amount of electrons. Let us consider 50 electrons are ejecting from this cathode tubes and constitute a current. Initially these electrodes having a certain potential and a certain current also, it increases at a particular, the current is going to saturate. Why current is going to saturate means intensity is fixed, that is, that we considering as I1. Intensity is fixed, that is 100 watt intensity is fixed. Only 50 electrons are going to eject from this cathode tube and current is constitute, increases. If the potential difference increases means also at a particular instant the current starts increasing, 1 ampere, 2 ampere, 3 ampere, 4 ampere, up to a certain amperes it is going to increase and again it becomes saturated. Now I am considering a amount of incident light is increased in the form of intensity. Initially it is 100 watt, now it is increased by 200 watt. Intensity of light is increases, that is 100 to 200 watt. The number of emitted electrons are also increases. On this particular cathode plate, the emission of electrons are also increases. Now if suppose we increase the potential, initially it is the positive terminal of battery is connected to anode and the negative terminal of battery is connected to cathodes, and these anode plate accelerate a positive ions and these electrons are attracted by those positive ions, constitute a current. Now the intensity increases, the number of emission of electrons are also increases. If we increase the potential, definitely the current is also increases. The current is also increases at a particular point it is going to saturate. This is called as I2, intensity 200 watt. Now I am going to increase the intensity 300 watt. Now intensity increases means initially it is 50, second intensity is 100, now the intensity is increases, now it is maybe 300, the 300 electrons are going to increases. Just I am saying 300, 200, just the sake of understanding, it is not fixed. If 100 watt given means 100 electrons will come out, not fixed. It depends on the metallic surface and also it depends on the nature of metals also. Though the number of electrons are increases, if the potential increases means here is also the potential increases and it becomes saturated. This is the third intensity. Here intensity of light increases. What is going to fixed? Frequency is fixed. The color of light must be fixed and at a particular instant, that intensity of light is decreases and photocurrent becomes 0. That point we are going to explain. Listen here. Now we increase the positively. Now this commutator, I am going to use this commutator, and this commutator helps to that is changing the polarities. Now I am going to connect like this. Now I am connect like this, and this positive charge ions are moving towards the cathode and negative charge ions are moving towards anode plate. If we increase the potential, that to negative potential, the negative ions are increased here. If potential increase means negative ions increases, those negative ions are repelling these ejected electrons. We will see that. Now let us consider this is the first intensity, that is 100 watt. Now 100 watt intensity of light is incidenting on the cathode. Now this positive charge is connected to cathodes. Positive charge means positively charged ions. If the intensity of light increases means, and here positive charged ions means the less number of electrons are present on that particular cathode plates. If even a small amount of electrons is there, those electrons are emitted with the help of this intensity. Now the negative terminal of battery is connected to anode, and these negative ions are repelling these electrons. Repelling means the current is decreases. Negatively increases. There is no constitution of current. The current suddenly it is not going to decrease. Suddenly it is not going to 0. It is decreases. Negatively it is decreases. At a particular point it is going to 0. At this particular intensity of light, at this particular point increases, it becomes 0. Similarly for second intensity of light also, intensity increases. Here is positive ions are moving, here negative ions is moving. If the potential difference is increases, potential increases means number of negative ions. Why? Because it is a negatively charged ions are going here and positively charged ions are going here. Now these negative ions are going to repel these electrons, and these electrons not collecting by this anode plate, there is a repulsion takes place, the decrease in this current. Again the intensity of light decreases, and it is going to 0. And it is also decreases, and it is also going to 0. At a particular instant, the negatively charged ions or electrons repelling by this anode plate, it is going to 0, which is going to 0. Photoelectric current is going to 0. At this particular point we called as V0, that we called as a stopping potential. Stopping potential. What is mean by stopping potential? Already we discussed. Stopping potential means a minimum negative anode is minimum negative potential is connected. Minimum negative potential is connected to an anode plate or is given to the anode plate. What happens? A photoelectric current is decreases or current is going to 0. The negative anode potential is given to the anode plate. it constitutes or it causes the decaying potential, the minimum negative potential is applied to anode just stop the photoelectric current. What is the definition of stopping potential? At this particular potential, retarding potential V0 is defined as the minimum potential is applied to anode, minimum negative potential is applied to anode, minimum negative potential is applied to anode to just stop the photoelectric current is called as stopping potential. This is the second effect of photoelectric effect. Now we will discuss the third one, and that is also very important. Effect of frequency, effect of frequency of incident radiation on photoelectric current. Photoelectric current, effect of frequency of incident radiation on photoelectric current. Now on the second we discuss the 100 watt, 200 watt, 300 watt. We increase the intensity of light. We increase the intensity of light. On this particular we increase the what we should increase? Frequency. And what is going to fix the intensity? Intensity is fixed and frequency varied. Varying frequency is varied, intensity is fixed. Now just see a graphical explanation. Now here is potential, just to consider the potential only, and this is positive potential, this is retarding potential. Or you just potential on the collector plate, and this is negative potential on that collector plate also. Now intensity is fixed, intensity of incident light is fixed, intensity of incident light is fixed, the variation of frequency. Now at a particular intensity it is increases, it becomes saturated. Saturation current is saturated. on increase of positive potential. If the potential increases, initially just you polarity change. First one is it is positively connected and it is negatively connected. Now see the first condition, it is positive and it is negative. The potential difference across the plates cathode and anode, the positive terminal of battery is connected to anode and negative terminal of battery is connected to cathodes. Now intensity is fixed. Let us consider intensity is now on this particular case intensity is 100 watt. Intensity is fixed. Intensity is fixed. But I am going to change the color, maybe yellow or red or blue. You can take any intensity, you can take any frequency variation. You just you change the color. Now at a particular intensity, intensity is fixed. Intensity of light is fixed. Intensity means 100 watt is fixed now. That may be yellow, that may be blue, that may be red. Now consider first case, first intensity, particular intensity. At a particular intensity it increases, it becomes a saturations. Now again this is the first bulb, just to consider any type of color, and now consider in the second one red. It is same intensity but frequency is different. Same intensity but frequency is different. Intensity is remain same means the saturation is also fixed. Now take the another color. Intensity is fixed, color may vary, the saturation current is same. Why saturation current is same? The photocurrent is directly proportional to intensity of light. Already we discussed intensity of, as intensity of light increases, the photocurrent is increases. Already we discussed. First I consider the yellow color, second I consider the red color, third I consider the blue color. Not increase the intensity, color is changed, at a particular level it is increases and it becomes saturation. Why it is going to saturate? Intensity is fixed. Even three colors, yellow, blue, red, it is fixed. But come to the negative retardation, polarity is changed. Now I am going to change the polarity. Polarity is changed. Now polarity, this negative, it becomes negative and it becomes positive. Polarity is changed. Polarity changed means if we increase the potential, if we increase the frequency, frequency increases. Yellow, blue, light, frequency is going to increase. Increases means, now just to consider first frequency, it is going to saturate at this particular point. Why? Because as resistance increases, potential is also increases, and negatively frequency increases means photocurrent is decreases. Photocurrent decreases means potential is decreased. Why? Because it is going to ripple. Ripple means electric current is decreases, potential is also decreases negatively, that negative retardation. Now take the another frequency, different frequency, red, it is decreases. Why it is going to change the retarding potential position? Why? Means frequency negatively increasing potential as negative frequency increases. As frequency increases, a retardation potential or retardation photoelectric current, we are seeing the photoelectric current, or see by different graphs. If yellow color retardation is this one, blue color retardation is different and orange color or different color retardation is different. This retardation, the stopping potential is different for different color. The stopping potential is different for different frequency, but stopping potential is same for same intensity of light, same frequency of light. Already we discussed in the second one. If the frequency is fixed, intensity may vary, intensity is different, stopping potential is same. But frequency are different, intensity of light is fixed, stopping potential are different. Frequency changes, stopping potential is also changes. The minimum negative potential is given to anode that stops the photoelectric current at different positions. Yellow may be here, blue may be here, different colors may be here. It depends on frequency of light, the stopping potential depends. If the color or frequency vary, stopping potential is also vary. If the frequency is fixed, stopping potential is fixed. This is the very important effect of photoelectric current. If the frequency is fixed, see once again, if fixed frequency just to consider new, frequency is fixed, stopping potential is fixed for different intensity, all type of intensity. If any type of intensity, maybe n number of intensity increases, also stopping potential is same, and that is the minimum potential. But frequency is varied, the stopping potential points are different. Photoelectric current is going to zero at a different potential. At a different potential, it is going to zero at a different frequency of light. Okay, have you got it? This is just to consider yourself. V01, this is V02, this is V03. V01 is the stopping potential of a particular frequency, V02 is the stopping potential of the frequency, and V03 is the stopping potential of the frequency. The stopping potential is depends on frequency also. Frequency varies, stopping potential is also varied. Okay. This is about the today class. We will discuss the remaining things in the next class. Thank you.